Alright, so day 8, inverse trig functions and transformations. So this first one, we have to describe the difference between these two. So basically, the first one, we're first having to take the sine of pi over 3, and pi over 3 is 60 degrees. And the sine of 60 degrees, that'll just be the square root of 3 over 2. And then you have to take the inverse sine of this value. The inverse sine of that value would be, let's see. So that means it's saying if the sine of an angle is this value, what would it be? And then you just get back pi over 3 or 60 degrees. But for this one, you have to look at you're basically saying this one is saying when the sine of an angle is pi over 3, what is that? What angle would you be talking about? But we don't express sines using terms of pi. We express it using like square roots, like the square root of 3 over 2 or 1/2 or 1 or things like that. So that means you would end up getting an irrational number, and taking the sine of a random irrational number would give you another irrational number. So that's how they're different. So when we do inverse trig, so when do they undo and when do they not? They only undo, and it only works for whenever in the case of sine and tan, whenever the initial value is between so we have to be looking at the right half of the unit circle. So it only works in the case of sine and tan whenever the angle is between negative 90 degrees and 90 degrees. Between negative 90 and 90 degrees. And then for cosine, since we're looking at the upper half of the circle, it would only work if the initial angle measures between 0 and 180 degrees. Then we have to discuss the graphs of inverse trig, sine, cosine, and tangent and why they're restricted. So basically the simple answer to this is because if there weren't restrictions placed on this, there would be multiple y values for one x value, and then that would prevent it from being a function. And we can't have that, because if we were to look at this, let's see. Okay, so I'm just going to draw a sample of how a tangent function would look like. It would look something like this, right? But then if we were to reflect it across this, if we were to reflect it across this, then this y equals x line, we would get something like this. And we can't have that, because look at how many y values we're getting for the same x value, and that wouldn't work. And it's a similar case for the other trigonometric functions, for cosine and for sine. So that's all for this question of the day.